welcome back to Dragonfly Engineering. So we're up in the clean room for this episode, and I wanted to give an update on the automation table, the robot automation table that we worked on a couple of months ago actually. So this is the one where we welded a base frame out of steel, and then we drilled the breadboard pattern into the top of this Mike 6 aluminum plate using Big Yellow. So there was maybe a month or so ago, that episode, so you can check that out. Anyway, so I went out and got this top plate black anodized at a local anodizing company, and they did a great job, and here it is assembled in the clean room. And I've already got the white robot mounted temporarily to the corner. So it worked out good, nice and flat, and the whole pattern, I've already started to make little fixtures that we're going to mount to this breadboard surface. And like I had mentioned in the previous episode, I'm only going to tap the holes that I need to if I want to drill or thread a hole and then bolt some different robot work features onto this table. Oh, and the molding machines and robots are running in the background. So sorry about that, it was heating its oil. All right, and now that the table is done, we can start to populate this table with more robots. So I have a new introduction, the red robot, which previously was a Samsung labeled Kuka Robot that was blue that I purchased last year on eBay from a local eBay seller. And it had like some Bondo work on it to cover up the Samsung logo, which didn't look that great, so I went ahead and finished it up a little bit better and painted it red. So without further ado, I'd like to introduce you to the red robot. Feeling that the four corners are touching, and we'll bring it down gently. There we go. So here's the red robot. Got to figure out orientation of the connectors, which are down in the base, to connect to the motor controller underneath the table. So I will carefully spin this thing around. I think we're going to have the cable cluster come out the side of the robot, but I can always reconfigure it as needed. Bolt in. So actually April prepped this robot for me to paint it red a few hours ago actually. So she took some of the panels off of the robot, and we're gonna stick those back on. Some of the kind of the caps that cover up all the bolt patterns for some of the main axes of the robot are just easier to take off. I think they're molded Delrin or acetyl anyway, so they don't really paint well. Boy, this socket is not fitting in here. Yeah, when Kuka designed this robot, they've got this this bulge in the circuit board pack for the bottom of the robot, which makes it difficult to drive in the bolts, but we'll power through it. Got this long bolt because we got to go through the robot, the table, and then this 2-inch steel tube. But I think this bolt may be a little too long, but I can optimize all this once I get the robot kind of dialed in. We can go back and change bolts. All right, so our new setup is the red robot, the white robot, which will probably be reassigned with a gray robot, which is yet to be painted, which is gonna go here. And the tabletop, the steel frame, and then the two robot controllers down at the bottom, down here, which will control these two robots. So I think the next thing we're gonna do is put the panels back on red now. This is kind of a panel that exists on the robot with the connection of all of the downstream axes go through this flex cable. And then there's a motor in the back there, which controls this axis. I'm gonna dig into April's kit here. Yeah, and in fact, this is just a cast aluminum plate, and it's covered in grease, probably to facilitate this this wire bundle and protective braid from not eroding and starting to cause shorts. So they grease the inside of this cover to protect this thing from abrasion. And she, you know, provided the screws in a little bag, and she even put the the Allen key in with the kit. That was nice of her. Other times when I buy these Kuka robots on eBay and they've been colored, people paint over this black panel. So in this particular one they didn't, and I kind of like the black panel look of it, and it's less work for me to do. Not to mention it probably won't paint very well if it's covered in this this whatever silicone grease or whatever is on the backside. So I'll probably have to clean the area again after I bolt this on. I'm staying on this side of the work table so that I don't get tangled up in the running robots in the background. Because you gotta keep your eye on them basically when they're running, so they don't smack you in the head. All right, and we will screw these on. I'll probably change gloves after this because I got that silicone grease all over them. There we go. And our final cover disc goes on like that. And there it is. Okay, we're back out here in the clean room and it's the second day. And today Orange is still working, but working on a different molding project. And Green actually has the day off. And I'm gonna probably take some of its components to get the new red robot and the soon to be painted gray robot up and running. So for today, oh, and there's a big air burst because the mold running right now has some air cylinders, some side pulls, so I'll try to edit out as much of the air burst as I can. Today we're gonna add the end effectors onto these two robots and then turn them on. So the end effectors are these aluminum cubes, which are similar to, let me see if we can, yeah, these aluminum cubes are what mounts to the end of the robot, and then all of the different tools that the robot uses can mount onto these. We're actually going to do two different types of tooling. So one will be using these magnetic kinematic bases, this thing right here. And we can bolt these on, which comes from Thor Labs, and onto the end effectors with an M6 screw and a little dowel pin to set the correct angle of this thing. And how these work is there's two plates and they snap together like so. So if you check these out, one side has 3 ball bearings and a bunch of high-powered neodymium magnets. And then the other side has basically sets of cylinders that makes like a V groove. And then when you slap these two together, it repeatedly mounts in the same position. And right now we've got a gripper claw on here. So this is a kinematic mount. This is, I believe, the 2-inch, and Thor Labs sells these, but they're not a sponsor or anything. They're just handy to use. And if you've seen Quinn from Blondie Hacks, I actually had her make a couple of these robot end effectors about a year or a year and a half ago. I don't recall. I've updated the design since, and now we've got mounting schemes for the kinematic mount, or just we filled it up with an array of just mounting holes, just threaded holes. And this fits onto the end of the robot using this array of mounting flanges, as well as this extension cylinder right here. So basically, yeah, it goes like this, and then a bunch of bolts go through this bolt pattern and then screws into the end of the robot. So let's go over to Red and attach our new end effector that my buddy made for me. He made like 3 of these. Okay, so our end effector cube and our extension cylinder is going to mount onto the, let's see, like this. I'm going to mount onto the flange of the robot right here, which is an array of M5 screws that go all the way around. And the reason why we've got this extension cylinder on the end of the cube end effector is that when this wrist number 5 spins all the way to its limit, which is like up here, we don't want the corner of the cube to actually hit we don't want the corner of the cube to come around and hit the wrist of the robot. You know, right there you can see how we would hit. So if we just mounted the cube like this, like actually Orange has, then I've had problems where the corner actually gouges into the wrist of the robot. So we extend this guy out like so, and we've got much more versatility on motion of the end of the robot. So let's go ahead and mount this guy on here. It may be a little difficult to see. I'll try to orient it this way. Okay, it may be a little hard to see, but on this end flange, which you mount your tools to, this flange rotates almost 360 degrees, and on this flange there's a little notch which sets the 0 angle or indicates the 0 angle. So we are going to orient the cube being aware of that little alignment notch right there. And then this little machined button tip fits into the center of the flange here. It kind of locks it in place. So it can't move around side to side. There's a little bit of slop for just assembly tolerance. It's not like a press fit, but it should, once all these, what is it, looks like 8 bolts go in, it should be pretty well repeatable and not moving too much. It's a little tricky to do all of this. So that side fits in there. There's probably an elegant way to do this assembly. There we go. So somehow I need to hold every screw, have the tool line up to our notch, find the closest bolt pattern, and then screw it in. And I won't lie to you, I've done this a couple times off camera to figure out this procedure. Because all the screws, since the robot is facing down, want to fall out of their corresponding hole pattern. So this bolt here is the one that I think wants to go into a dowel pin hole. Maybe not, let's see. Yeah, it's just spinning in there, so I'll pull this one out. Oh, okay. And the dowel pin hole lines up with the alignment notch, which is kind of handy. So we will have one less screw. I guess I could probably stick a dowel pin in there, but it's not really designed for that. All right, and here is our end effector. I guess while we're here, I will insert our Thor Labs. And this also requires a dowel pin, which I don't have right now, so I'll put the alignment dowel pin, the little drilled hole right here, to a reamed M3 dowel pin hole in the top of this guy. I'll put that in later. And visually, I'll just line up the front of the kinematic mount. Actually, I can use the second cube as a gauge block. Let's see if we can get that in camera. So for now, I'll use our second end effector as our kind of a angle setting gauge block, which is sort of what the dowel pin would do as well. It's funny with these Thor Labs mounts, they only give you a single bolt hole in the middle to mount this thing. So this top surface is all super accurate, repeatable, but they don't really give you a way to lock this plate into the thing it bolts to, because there's only a single countersunk hole in the middle for mounting something. So who knows? Anyway, so now we can offer up our robot claw to our red robot, which happens to be red as well. Isn't that nice? And then this one I use on other setups for other robots, so it already has its push to connect air hose. And then this claw is a spring return. You guys may recognize this tray for some of the recent projects I've done. So our dowel pin hole and our alignment notch is right here. So we'll stick the empty slot there, or the empty bolt pattern hole there, and do the same thing we just did. All right, so under the table are the two robot controllers for the gray and the red robot, and each one has its own corresponding control pendant here. And then a lot of cabling and stuff. I may actually hang control pendant hangers off of the side. These robots come with like a sheet metal structure that you can hang your control pendant off of. But I may wind up just setting it right on the controller itself. And then all the action is at the front of these controllers, so maybe let's take a look at the front there. Okay, so here we are under the new robot integration table. And these are the two robot controllers. Controller cable here for the hand pendant, which is the same as this guy. And then we've got the data cable for the robot itself, which is positional information, power cord, and then the power cable for the robot itself. And then 220 volt single phase that connects these two, and to a power line that goes off to the wall. So it's a little messy, but you kind of wind up with that. I mean, cable management is always a thing. And then there's going to be more things under here as well, such as a temperature controller and probably like a Raspberry Pi module with a bunch of things that control pneumatics like you're hearing in the background, or temperature like I just mentioned, or even little test fixtures and things that the robots will interface with above. And then looking at the back of red here, you can see the other end of those cables. This is the power, and this is the communication cable to the little control circuit board inside of the back of the robot. Okay, so the idea is that these robots sitting on this work table will hand off parts with the other robots in the room, such as, you know, green can work with red, red can work with white, white can work with orange up there, and either orange or white can work with the other white robot. Actually, that one's going to be called gray, just so we can keep a interesting color scheme. And then over here, blue hopefully can reach down to red. Red is a longer reach, but I may wind up moving this big molding machine out of the clean room, because a lot of its jobs don't really require the clean room per se, and I'm running out of room in the clean room for more automated assembly for some of my day work. So anyway, that's what we got going on with the robots. So as far as the layout of the room, so this is kind of what we're seeing here. All right, well, let's get red turned on. Maybe we can turn on white, but I may have to borrow some safety cards, basically some interlock emergency stop cards from other robots to turn these on temporarily to see how they behave and how they reach around. And then we are booting up the two controllers for these two robots. Let me get some of this out of here. My little parts tray. And we'll see that both of these guys can work. I don't know if you recall from the episode where I used the big yellow robot to drill all of these holes. but there's also a spot in this corner and a spot in that corner that other robots can work. But I think 2 robots working on this table is probably a decent density of robots for the amount of possible areas of work that can occur here. Back here, I think I'm going to add like a pedestal, because right now Orange is clipping parts from a clipper that's attached to the wall of the clean room. But I think it's better that Orange reaches over to this table with a pedestal I'll move the clipper that's over in the corner to the table so that this robot can grab the part while Orange tells the clipper to clip, and then it'll throw away the sprue or the runner, and then that part will be in the hand of the white robot that can then assemble parts together. Okay, so we've got a clean bill of health on this robot. And we got a clean bill of health on this robot. It's telling me that, whoops, I dropped a part over there, that it can't see the 24 volts. I haven't set up 24 volts yet for the I/O modules. So let's see if this guy will actually activate. I may have to put 24 volts on these. Oh, okay, well this one was happy. So let's see how we do here. This is the red robot's controller. So I'll speed up the jog and I'll move around on these axes. So right now we're in axis mode. Let's see if you can see that. So axis 2 is like this. Axis 3 is like so. I got some touch up I need to do on the red paint. So I'll switch to world coordinate mode so we can move the cube around in a linear coordinate system like that. And we'll come down in Z. You can play around with the angles. I see a few more spots where my red spray paint missed. And we'll come over to the other room, or to this molding machine behind me. That's pretty good. Go up in Z. We'll change around the wrist orientation. Kind of seeing if the red robot can actually reach up to where the blue robot would be able to hand off parts. Looks like it can. I also don't want to tip the table over. So we'll check our reach. Yeah, it's pretty good reach. I think the blue robot can work with this one as is. I need to change my bin behind me. The parts bin is getting full. So that's cool. And then we'll check to see if the end effector cube will hit, and it didn't. The robot basically went to an axis limit there, or a travel limit, so it wouldn't hurt itself. So we are good with red. I have to see why white doesn't want to turn on. All right, I think I figured out what's up with the white robot. Whoever had this before me, I bought this one on eBay. I kind of recall they just shoved wires right into the D50 connector that controls all the safety switches and emergency stops and everything. Excuse me, and everything. And as I recall, they used maybe too high of a gauge of wire. So I think the connector actually I probably need to change out, because some of the pin ports the crimps are probably opened up too much. So it's a shoddy connection, which is what you don't want in a safety circuit for a robot. So I may have to do a little bit of work on that. But for now I got it working, and I'm just at a safe distance. So we'll check out how this guy works. I've tested this one before, so I'm just kind of making sure that we are good. And it looks like we are. So I'll go to world coordinate system and make sure that it understands its shape and its space that it's working in. And we can play around with the A axis on this one. Yeah, so our interest is like how this guy can work with the its neighbor robot on the next table over to hand parts off. I also have like staging areas to transfer parts and things like that. So this is looking pretty good. And that's about the limit of its reach right there, just locked up. Oh, it actually said workspace error. Okay. So I think we are set for these two robots. Let me bring it back over its table so I can walk through here after I shut it off. I'm in teach mode right now, so the jog is kind of slow. But you can see how it's holding that cube in the right orientation until I change it by playing with the three angles, A, B, and C. So I'll keep it moving that way. Just to illustrate that what will be gray and red can work with each other because they're overlapping their workspace. And then we come down in Z to the tabletop, ideally not whacking my new table that I machined. But yeah, this is some examples of its articulating ability. So I'm pretty happy with what we got going on here. Now I gotta basically populate this table with little work cells and tools for these robots to start assembling stuff, which should be fun. I got another update for the DoAll saw, which I also bought on eBay, picked up in LA. Oh wow, I see an old airplane flying in. It's an ancient FedEx plane with the engine and the tail. Anyway, sorry. So let's go next door to where the DoAll saw is. I got some new belts, or a new belt in, which fixes the belt squeaking mechanical alarm that the saw has. And I've got a wood blade on there because the first project I'm going to do is to work on sawing up some logs from an almond tree, an ancient almond tree that finally died in the backyard. So I cut that thing down and I'm starting to get a log squared up to use that saw to cut planks off and maybe make a toolbox or something out of it. We'll see. So I will meet you over next to the DoAll machine, or the DoAll saw, and let's take a look at some of the improvements that we've done to it. All right, so here we are back at the old 1965 DoAll bandsaw. And I think I've made a little progress. There's one belt in the back that we updated. And if you recall, this thing sounded pretty rough before when it was running with the original belts that probably sat in one belt orientation for maybe a decade or two, because they definitely had like sort of a set to them, and they're kind of hard and crunchy a little bit. Well, one of the belts I was able to replace, which I think is the one that had the more wear and weathered effects to it, and that's the belt that goes between the drive motor and the variable speed drive. And also I think the contactor quieted down a little bit. So let's try a comparison. I've got the clip from when I first turned this machine on here in the shop after we got it out of the van with a quasi-disastrous rigging operation. And now we've got the current sound. So we'll first hear what the original saw sounded like. Here it is. I think I've got some contactor hum. And now we'll hear what it sounds like after a little bit of work, but not too much work. So we'll click the old start button. That sounds a little better. I've got it up at an RPM that's more appropriate for cutting wood because we got a wood blade in there. You can see our 12-inch depth of cut here, which is what I need for that log that we're going to cut up. So go ahead and stop it. And let's take a look at the belt and the situation in the back. All right, so this is the new belt that I bought from somewhere online. These are still available, and it's nice and soft. And then up here is the original harder belt, this guy here, which I'm having trouble finding a source for this. So I may just, run it with this belt and eventually find a softer belt, but it's actually working out pretty good. And we don't hear the squeak anymore down here at the motor. So down here at the motor, there is a squeaker tab that would indicate that I needed to change. Now where is that? Actually, I think it came off. I need to find that thing. Or just leave it off because it sounded so bad. But there was a piece of metal which actually I need to replace, I think. Where'd that go? Yeah, there's a... Let me find that, actually. Oh, I think I put it on the back. So, yeah, there's a bar of metal which I bolted to the back of this motor that extends beyond this notch, that couples into this nut that holds the motor onto this rocker carriage. And that piece of metal would scrape against this tab here and cause the noise telling you that it's time to change your belt, I think. And then this tab actually rolls down out of the way. I'm going to drop this blade guard down to about there. This is a 3/4 inch wide, 4 tooth per inch saw blade for cutting big pieces of aluminum or wood. And we'll even try out our little air compressor, make sure after I put that new belt on that it works. Okay, here's a section of that almond tree wood. It's got a lot of cracks in it. I'm hoping I can salvage a lot of this, but it's got some pretty interesting grain to it. This was a branch that was probably 7 inches in diameter. So here's another shot of the interesting wood structure in it. I may actually fill in these cracks if the bigger log has a bunch of these kind of funny grain cracks in it with some of that epoxy infusion that I see some of the woodworkers do. There's a guy who does tabletops and he epoxies in the voids in the wood with black epoxy. I may try the same thing. But let's try this test piece here. See how our saw is working after the loud muffler goes by. All right, fire it up. Oh, I should have tested the air compressor. Let's see if that works. Yep. There we go. So anyway, that's some of the inner grain. It's got cracks all throughout. It may have a couple of termite holes too. So anyway, it works. It's getting better. Well, I think that'll be a wrap for this week's Dragonfly Engineering. I know it was kind of a short episode, but it's end of the year rush to get everything done for customers and everyone. And the following week, I am going to be visiting a special location in Texas and hope to get some footage and some commentary of a field trip for Dragonfly Engineering. So stay tuned to that. I may be able to release that maybe a few days after Christmas. We'll see how things go with travel and all. So if I don't see you before Christmas, then have a Merry Christmas and Happy Holidays, and thank you for subscribing. Thank you very much for my patrons who help support this channel, and I will see you guys in about a week and a half. Thanks for watching. Goodbye.